Hello students, good evening to all of you all. Assalamu alaikum. Welcome to the online session. Can you all hear me clearly and see the screen clearly? Am I audible to you all? Am I audible to you all?
Yes, sir.
Okay, thank you. So let's go into the discussion. This is related to a very simple lesson, resultant and equilibrium. It's a physics lesson, and actually out of the physics lesson, one of the easiest lesson is related to resultant, equilibrium, and turning effects of force. I have not put those questions. Those three lessons are actually very easy lessons. You can score the marks from them. Okay, the resultant force acting, question number one, the resultant force acting on the body and the direction in which it moves respectively in this given situation. Yes, can you all hear me clearly? If there is any coverage issues or network issue, just let me know. Okay. Yeah, let's go to the previous picture. Here you can see there are four forces. One force is acting upwards and the other one is acting downwards exactly below it. So when finding the resultant, first we will check upward downward force, then left and right forces. So here what is going to happen? The upward and downward forces are going to cancel each other because the values are same. It's a collinear force, opposite in direction, having the same value. Then 3 minus 3 will become 0. So upward resultant is 0, upward or downward resultant. The azan is going on. Give me 2 minutes. I will mute it and then we'll continue. Okay, then let's continue. Here, look at the left and right forces. We have a 4 Newton force here and a 2 Newton force here. It's very simple. It's in the opposite direction. So, collinear forces or parallel forces in the opposite direction, we have to subtract. The larger force minus the smaller force. 4 Newton minus 2 Newton. We will get the answer 2 Newton. Direction will be towards the larger force of the direction of the larger force. So, 2 Newtons to the west. So this is pointing towards the west direction. Always you all know the compass directions, north, south, east and west. So if the arrow is pointing this way, it is towards the west. I hope you all are clear. It's a very, very simple, easy question. Anyone can do it. Next one, an object having a weight of 50 Newton was given an external force of 80 Newton. Find the resultant and the acceleration of the object if it is placed in a smooth, frictionless surface. Okay, now, this is a good question related to fourth lesson, forces and its application, the Newton's law, all those things. So it is kept in a frictionless surface. The weight of the object is 50 Newton. If the weight is 15, what about the mass of the object? You have an equation W equals mg. Weight equals mass into gravity. So weight is given as 50, mass is unknown. Always gravity value is 10. So 50 divided by 10 will give you the mass value. Therefore, mass is 5 kilogram. This object's real mass is 5 kilogram. Weight is 50 Newton and it is being pushed by 80 Newton force. We don't know to which direction, but somehow it is being pushed. You can put any direction, pushed or pulled or whatever. Find the resultant and the acceleration. Now this is a frictionless surface. There is no opposite force. And also from the other side, so anything, nothing is mentioned related to any opposite force. So the external force is the actual resultant force. Resultant force is 80. Now don't think this 50 Newton, you have to minus 80 with 50 because 50 Newton is the weight of the object that is acting downwards. The external force is acting in a way to move the object. It might be acting from left to right or right to left. Okay, so that and these are not getting subtracted because those two are in two different planes. Okay, now what about the acceleration? To get the acceleration, we use the Newton's equation, Newton's second law equation. F equals ma. External force applied on the object is 80 Newton. Mass of the object is 5 kilogram. Acceleration is unknown. 80 divided by 5 will give you the acceleration. So the answer is 16 ms minus 2. Here, here there is a small mistake. Everything has become ms minus 1. Acceleration units are ms minus 2. Change everything to ms minus 2. That is when typing it has got accidentally ms minus 1. So the answer will be the first one. 80 Newton resultant force. Acceleration is 16 ms minus 1. From the weight of the object, we are able to find the mass of the object. I hope you all are clear. If you have any doubts or any problem, just let me know. So 80 divided by 5 is 8. Who's that? So the 80 divided by 5 is 16, no? Okay, the resultant force is, it's a very simple question. This is collinear forces. The definition of collinear force is the line of action of one force and the line of action of the other force are in the same line. That means when you extend this force and when you extend this force, it's in the same line. So here, the larger force, to get the resultant, normally we use larger force minus small force. Larger force is 80 Newton, small force is 20 Newton. Answer will be 60 Newton. Direction will be the direction of the large force. This way direction. So here in the answers, they have not bothered about the direction. So you get the correct answer. That's okay. But if they give you the direction, if there is answer with this side direction, or they mention as west, then select that answer. Hope you all are clear. Answer is answer number 2. Second question answer is answer number 1. Question number 3. The rod is in equilibrium. That means both way it is balanced. Huh? Clockwise moment is going to be equal to the anti-clockwise moment. The magnitude of force P. They are asking for the magnitude of force P. Good question. This is related to turning effects of force. So, Puta Balanda, this is the pivot point. Okay, this is the pivot point. From the pivot point, when there is a distance and a force, we can use the equation force into distance to find the momentum. Not the momentum, sorry. Moment of force. Moment of force. But on the pivot point itself, if there is a force, that force will not be considered. So here, this 10 force is not going to help this side or this side. It's just in the middle. It's not affecting the momentum. First, you have to understand that. Then, you know, these two forces are acting downwards. So, and it is connected to the rod like this. So, it will rotate this way. This is known as anti-clockwise. So, the moment there is going to be anti-clockwise moment. This side force is connected with this rod. Therefore, when it rotates, it will rotate like this. If it rotates, that is clockwise. According to our equilibrium concept, clockwise moment is going to be equal to anti-clockwise moment. So, in the center, I am going to put an equal sign and write anti-clockwise moment is going to be equal to, sorry, this side is anti-clockwise. Anti-clockwise moment is going to be equal to clockwise moment. In symbols itself, I have shown. Then clockwise moment is easy because there is only one force and one distance. So F into D, according to that concept, I can put 150 Newton into 3 meters. This side, I have two forces. So for one, I have to put FD, and then for the other one also, I have to put FD. Now let's say for this, and then for this. For the first one, it's going to be P into 3. Force value is not given, no, it's P into 3. Then other one is going to be 3P into 1. In momentum, we always take the distance from the pivot point to the force point. From here to here, it was 3 for this force, but now it's from here to here. 3 plus 1, 4. They only normally the students make the mistake. So now it's totally maths. 3 into 4 is 12P plus 3P, that is 15P, is going to be equal to 450. So 450 divided by 15 is going to be equal to P. 30 Newton is the answer. 450 divided by 15 is 30, and the answer is going to be Newton because this is related to force. Are you clear about it? If you have any doubts or any problems, you all can ask. I use FD for this, FD for this. Distance was 3 here. Here distance is 4 because from the pivot point to the force point, it's 4 meters. We did not select this because it's on the pivot point. It's not going to affect the clockwise or anti-clockwise moment. Yeah, the ones who don't know this, you all can take a screenshot. Again, later you can try and see. Once you divide, you will get 30 as the answer. So 30 Newton, third one is the answer. I hope all of you all got it, huh? At least majority of you all. Then let's move to the next one. Question number 5.
படிச்சு போறேன் கிளாஸ் போடலையா
A box of mass 7 kilogram was pulled from both sides by 2 kids. From one side the pull was 75 Newton and from the other side the pull was 26 Newton. Find the acceleration of the box if the surface was smooth. 75, 26, 7 kilogram object. So one side is being pulled by 75 Newton. The other side of the box is being pulled by another kid, 26 Newton. And the mass of this box is 7 kilogram. An object is kept in a smooth surface, so no friction. So the external forces, there are 2 external forces. All the data are correct, right? There are 2 external forces. The object can't move to both directions. So finally the object will move according to resultant. So how to get the resultant? Resultant equals 75 Newton large force minus 26 Newton the small force. Because there are only 2 forces. Then resultant will be equal to, when you minus this, 49 Newtons towards this direction. So it's like finally the object is being pulled towards this direction with 49 Newton. Both the boys are pulling it, but one boy's pull is larger. Therefore, the object is moving towards him. But this 26 is cancelled from the other side. That's why 49. So the resultant, now the object is moving with 49 Newton. If you are putting F equals MA, the F is the resultant, not the real value. Then force is 49 Newton. Mass of the object is 7 kilogram. Acceleration is unknown. 49 divided by 7 will give you the acceleration. 7 into 7 is 49, no? So then the answer will be 7 ms minus 2. That is the acceleration. So object will move with the acceleration of 7 ms minus 2 in the direction of the large force. Are you clear about it?
Yes, sir.
Yeah, anyone who wants to take the correction or a screenshot, quickly take it down. Actually, physics is more interesting because the maths part is involved. It's like a challenge, right? Now, bio becomes boring because the ones who memorize will get the marks, the ones who don't memorize will not get the marks. But in physics, it's not like that. The ones who understood the concept and the ones who can do the maths properly will get the marks. So everyone can try physics questions. Only thing is that fear of physics should go away. Some people for life get scared. I am weak in physics. Before even doing the questions, they say I am weak in physics. Same with chemistry calculation. The newcomers, you all can go to our YouTube channel and watch all the grade 10 previous paper classes. It will be really helpful. Now it's third term now. Now you all have to put a proper effort and revise all the first term, second term lesson. Again and again, I am telling you, grade 10s, okay, maybe until grade 9, when you get promoted to the next grade, you will forget the previous grade lessons or concepts, all those things. For example, from grade 7, when you are promoted to grade 8, and when you are studying grade 8, grade 7 concepts you might forget, 1 or 2, it will continue, but others you might forget. But that was okay. Same thing happened in grade 8. Same thing happened in grade 9. Same thing happened in grade 10. That means you have, now if I ask some of the students the grade 9 questions, half are like looking up and waiting. Okay, for now, okay. But when you go to grade 10, grade 11, and then if you forget the grade 10 lessons, then you will have to come to grade 10 classes again and study because O-level, majority of your O-level question depends on grade 10. So now itself, okay, now itself make sure you all are doing the proper revision of grade 10. Okay, or else again somehow while studying grade 11, you'll have to struggle, then study the grade 10. So now itself, cover up all the missed lessons, write the notes. If you are attending my classes, if you all have missed any classes or any months, you can go to that specific month and purchase the recordings, watch it, complete the notes, do the revision, and be prepared for grade 11. Or else somehow you will have to do this even while you are in grade 11, and that is going to be a big struggle while you are in grade 11. That not only for science, for almost all the subjects, grade 10 is like the real important thing. So do the revision, and complete all the missed lessons and be prepared to face grade 11 properly with enthusiasm. Okay, in order for a system of three non-parallel forces to be equilibrium. Okay, if you look at non-parallel forces, three forces equilibrium, it's something like this. This is the weight of the object, and these are the two forces which are holding the object. Or else there is another situation, the handbag situation, or hanging a picture frame with one string. Tension, and the weight of the object, W equals mg. W equals mg. This will be the tension, and this side will be the tension. Here also tension. All these two are the best example for three non-parallel forces which are under equilibrium. The three forces should be in the same plane. Tell me one word to cover this whole thing. It should be in the same plane. What is the one word?
Coplanar.
Yes, coplanar. Okay, it's known as coplanar. Not collinear. Someone has put collinear. Collinear means it's in the same line. Coplanar means it's in the same plane. Their line of action should meet at a common point. Now, wait, we'll draw extended version of this. Now let's say this is the object, like a banner is being hung like this. And this is the weight of the object. W equals mg. This is the tension. This part is also tension. Now, if you extend the line, that is known as line of action. This force line of action. This force line of action. And this force line of action. Can you see they are meeting at a common point? So whenever there is a situation where there are three forces which are non-parallel and under equilibrium, then all the line of action of all three forces will meet at a common point. Even this example, it's the same. Tension, and this is the weight. Weight will draw the line of action. Line of action of this force. Line of action of this force. Line of action of this force. When you extend the line of action, can you see they meet at a common point? This is only possible for three non-parallel forces which are under equilibrium. Are you clear?
Yes, sir.
If you want, take a screenshot. Let's move to the next one. Let's move on. Yeah, these are the examples for equilibrium under three non-parallel forces. Tension, and the weight of the object. W equals mg. tension, W equals H. Hope you all are clear. Then there's a question, what is meant by normal reaction force? Yes. The three forces must be collinear. The line of action of three forces must meet at a common point. The resultant of any two forces must be equal in magnitude and opposite in direction to the third one. We'll see, I think we have not completed that question, Palanda. The resultant of any two forces should be equal to the magnitude of the third force and also should be opposite in direction. So here the answer will be equal in magnitude and opposite in direction. But in your O-level syllabus, these are angle questions, right? Is the mention is divided into two. No. The resultant of any two forces should be equal resultant. That means you can take these two forces. The resultant of these will be equal to this force, third force, the value. But the direction will be opposite. Now the thing is, in our syllabus, this angle calculation will not come. Because whenever there is a force with an angle, there is a special A-level concept to do that. So, for example, if I say this is 50 Newton, this is 50 Newton, can I say this is 100? No, Buddha. We cannot say. Because that is possible in three parallel questions, three parallel forces. Those kind of questions, it is possible. If the question was something like this, 50 Newton plus 50 Newton will be equal to 100 Newton. This situation is correct. But here, Buddha, actually in A level only you will study 50 cos theta, you can get the upward force. This side 50 cos theta, you can get the upward force this side. Those forces will be equal. So here the best thing to say is, you can't use the word addition of two forces is equal to the third one. We have to use the word resultant. Because when checking the resultant, you have to check the angle and only check. But that calculation method is not there for O-level. So we are safe. They won't give any value related calculation for non-parallel forces. They can only ask these three concepts. Here I'll show you the concepts. If you memorize these concepts or if you understand this properly, that is enough, because no number or value related calculation, because you can't calculate. You don't know that cos theta, tan theta, that method in physics, no? So, non-parallel forces, no calculation. These are the three concepts. Yes. Question number 7. The mass of a bicycle rider is 50 kilograms. The force acting on the bicycle is 150. That means he's pedaling with 150 Newton. Okay. While the force acting against the motion is 70. Now you all know there is some like air resistance, no? So when he is riding the bike, maybe air resistance, maybe friction. Okay. Friction might be occurring. This is the force he is putting. He is putting 150 Newton. But somehow 70 barrier is there. Maybe air resistance and friction. Both together it is 70. The weight of the bicycle and the person is 50 kilograms. Balamuko. The mass of the bicycle rider is 50. The two forces which resist the motion of the bike are generally air resistance, and even for a plane, even for a bird, the air resistance is there, no? If it's a fish, water resistance. Reducing the speed of the fish, water resistance. And other one is friction. Contact force between the flow. Yeah, it's like the drag force. Friction force is like the drag force. Because certain cars and all, very high speed cars, after finishing their race, they put a parachute like this, no? Then they have the drag force to stop the car. It's like a air resistance, a type of like a friction. The unbalanced force here is 150 Newton minus 70. So it's going to be 80 Newton. That is the unbalanced force here. The acceleration of the bicycle. Here there is a small problem. Why? They have given the weight of the bicycle rider. What about the weight of the bicycle? That also should be considered, no? You think that bicycle and the rider together it is 50 kilogram. Then only you assume like that and you put the equation F equals ma. Here the force will be the resultant force. You can't put 150 Newton. Even though the bicycle rider is putting 150 Newton, all that 150 Newton is not used to move the bicycle because 70 Newton are wasted in overcoming the friction and the air resistance. So that remaining force is only applied on the bike. The remaining force only we found out, resultant. 80 Newton equals mass of the bike and the rider is 50 into A. So 80 divided by 50 is going to be the acceleration. Therefore, acceleration is going to be this and this will get cut. 1, then point here. 30 means 6, 1.6 ms minus 2. Are you clear about this? If you have any doubts or any problems, please ask. Question number 8, very easy one. An instant where the resultant force becomes 0. Resultant force, for the resultant force to be
So what is the answer?
by 7:45, I'll give the time for prayer. Yes, Pata, what is your doubt?
So what is the answer, sir? Seventh question last time.
Which one? Seventh one. 1.6. From this equation, we did the calculation and got the answer. Harine? Yes, let's move to the next one. So, Buddha, some of the diagrams, we can just directly ignore the diagram. 6:45, I'll give the prayer. I said accidentally 7:45, 6:45, Buddha. I'll give the time for prayer. Yeah, with this question, we can go for the prayer break. So, Buddha, look at this. Do we need to do the calculation here? Here we know the resultant will never become 0 because all the forces are in the same direction. So it will be added, no? So you don't even need to waste the time doing that calculation. So when you see itself, that is rejected. Rejected. Next one, possibility is there. These two are in the same direction, 5 plus 5, 10. But here, minus 5, resultant will be 5 Newton towards this direction. So therefore, it's not the answer. They're asking, in which instance will the resultant become 0? See the next one, 15 Newtons towards this direction. Here 10 Newton, 10 Newton. First you can add those two. Same direction, right? 10 plus 5, 15. Then when you compare this force and this force, they are opposite in direction. Therefore, subtract is 15 minus 15. Resultant is 0. Therefore, that is the answer. Third one is the answer. Fourth one, 15 minus 10. There is a resultant of 5 Newtons towards this direction. Therefore, the most suitable answer, where the resultant becomes 0, is the third one. Yes, if you have any doubts related to the questions which you have done until now. Yeah, I think we can do one more question. Question number 9. Linear forces are acting in, okay, that means collinear or linear forces. Look at this. One force this way and one force this way. Both the forces are. So why not first answer in the eighth one? Wrong, no, Buddha. Look at the direction. This is same direction. This is same direction. This is same direction. All are towards this direction. 5 plus 10 plus 15. Total resultant is going to be arrows direction of the forces 30 Newton. That is going to have the highest resistance out of all the questions. Clear? Here, this is not collinear because it is parallel. No, weight of the object will act like this. This is acting this way. This is acting this way. Here also it is acting in different angles. Here, two parallel forces. This force is parallel to this. This is known as couple of force situation. If we have questions, we'll do related to it, but it's not falling under linear or collinear. Linear or collinear means the line of action should be in the same line. Only the first one is having that. All the others see this line of action here, line of action here, line of action here. This line of action, this line of action. Line of action, line of action, line of action. No one has line of action, one on top of the other. But the first one, if I draw the line of action of this, I'll use a different color. This side force line of action. This side force line of action. They will overlap each other, no? That's why they are known as linear or collinear. In our syllabus, we call it collinear. Then the diagram, question number 10. The diagram shows how the forces are acting on an object which is kept on the surface. Select the correct statement. Now, first we'll find the resultant. Always before finding the resultant, if there are multiple forces, take all the forces which are having a direction to one side, same side direction. Now see, this 17 is this side, 17 Newton. This side, what are the forces? 5 Newton, another 5 Newton. Look at the arrowhead. This way, no? Another 7 Newton. So 5 plus 5 plus 7 is 17 Newton towards this direction. This one has 17 Newtons towards this direction. So obviously what will happen to the object? Resultant of the object is 17 minus 17 because opposite direction, resultant is 0. So Balana, the object X does not move. Yes, it is correct. The object X moves towards the force 17, force 5, nothing because the object resultant is 0. Object is stationary. We can say object stationary at one place or object at rest, object at under equilibrium. You can use all these words to mention that it's in one place without moving. But forces are acting. Even though the forces are acting, the object is not moving. Are you clear about it? Yes, Buddha. Then we'll go for a break and we will start from question number 11 at 7 p.m. If you have any further doubts, you can send me through the chat box.
Assalamualaikum. Bapak Garet.
Okay, students, let's go back to the discussion. I hope you all can hear me clearly and see the screen clearly. Yes, am I audible to you all, Pudha?
Yeah, sir.
Okay, thank you. So, an instance when an object is not equilibrium under a group of force. Now, actually, it's like this. Here, they have not given values. But if the values are given, if you put your own values, can this be brought into equilibrium? That is the question. For example, this object, if I put 10 Newton and 10 Newton this side, obviously both sides will be balanced, resultant will be 0. So there is a possibility to make this object, even after applying the force, to be at rest. But the second one, Balanna, if you put 10 Newton here, 10 Newton here, and 10 Newton here, the object will not move left and right, but the object can move upwards, no? Because you are putting an additional 10 Newton there. To balance that force, there is no opposite force to balance it. So whatever values you put, you can never balance this. So this will never be under equilibrium. Here, let's say you're putting 10 Newton upward force and a 10 Newton downward force. Yes, you can balance it. At a point, it will get balanced. Fourth one also same thing. Left and right 10 Newton will get balanced. Up and down 10 Newton, all will get balanced. There are 4 forces acting on this object, but still this object will not move. Resultant will be 0. So here also resultant can become 0. But second one, whatever you do, whatever values we put, we cannot make the resultant 0 because there is a unbalanced force here. So therefore, second one is the most suitable answer. Hope you all are clear about it. There is gravitational. No, look at the object like you are looking at an object from top. Then think of this situation. Now don't think this is in the ground. Think of object which you are looking from top, overhead view. Then this is possible, no? Yeah, someone wants the 10th one. First one is the answer. Object does not move because left side, right side. So second one is a must to have a force in the opposite direction. Yes. Here, if the values are different, it will not go under equilibrium. But there are chances where first one, third one, and the fourth one can come to an equilibrium. But second one, Pudha, whatever you do, whatever values you put, it will never become equilibrium unless you put an opposite force this way. Because there is no opposite force, to balance this will not reach the equilibrium. I hope you all are clear about it. Here the 10 Newton is the value which I put. You can put any value and check and see. Hope you all are clear about it. Next one, question number 12. The masses and the magnitude of the external force acting on 3 objects A, B, C moving in a straight line is given in the table. The objects with equal accelerations are. This is actually a O-level paper, old syllabus, 2013. But some questions are applicable for the new syllabus also. So from there, I have selected 2013, question number 32. Very simple question. It's like this. The force is given, mass is given. We have to check the acceleration. If there are equal acceleration, that is the answer. So we'll put a column for acceleration. To get the acceleration, we know we are using the equation F equals ma. Therefore, acceleration equals force over mass. Here the force is 3, mass is 1. 3 divided by 1, acceleration is 3 ms minus 2. Second situation, force is 8, mass is 2. Force divided by mass will give the acceleration 4 ms minus 2. The third one, C situation, external force is 18, weight of mass of the object is 6. 18 divided by 6 is 3 ms minus 2. So A and C situations are having same acceleration. So we can go to the second one as the answer, A and C. Are you clear? If you have any doubts, you can ask. Give me 1 minute. Okay, let's move to the next one. Question number 13. Consider the following statement. A, forces always act individually. So is the paper available in the group? Yes, it's available in the group. Today only I have uploaded it. Acting individually means, now when you take a force, normally this force acts individually. And if there are multiple forces, they act individually. Finally, the resultant will be a collection of it. So generally when you say force acts individually, yes, it's correct. But when there are many forces, finally everything acts individually, and finally we get a final resultant force. So this situation for a situation where there is one force, it's 100% correct. But if there are multiple forces, they don't act. Finally, they don't act individually. If there are 4 forces, the object should break into 4 pieces and go in 4 directions. That doesn't happen. No. Finally, they come to a final force that is only known as resultant. So when there are multiple force, this statement is not that much correct. Okay, so according to the answers, we'll see. If 3 forces happen to come to equilibrium, they should operate on the same plane. Yes, in our O-level syllabus, we have 2 situations when there are 3 forces. One is parallel situation like this. The other one is the non-parallel situation. Earlier also we did that, something like this. Both situations, it should be coplanar in the same plane. So that is 100% correct. No change in that. If 3 forces happen to come to an equilibrium, they should operate on the same plane. Yes, they should be coplanar. No second word in that. 100% for all the situations, whether it is parallel, whether it is non-parallel or parallel, it's common. There can be uniform velocity for an object when the resultant force is 0. Can there be? 1 minute. Okay. There can be a uniform velocity for an object when the resultant force is 0. Now, this situation, Buddha, they are saying can be, no. It's not like there must be. If they put must be, that statement is wrong, but they are saying there can be. So, what is the situation? It's like already the object is moving with a velocity, let's say 2 ms minus 1, and the surface is frictionless. Now, someone is putting 2 forces, 2 Newton, 2 Newton. If the object is already moving, and at that situation, if someone is putting 2 equal forces, resultant will be 0, but object will be moving. Especially, let's say, in the outer space. Okay, you all know the Newton's first law, no? An object will be at rest or will continue to be at motion unless an unbalanced external force is applied. Here, when balanced forces are applied, this can happen. So there is possibility for this to happen. So therefore, C is correct. C can happen. Yes. It's like not a must. Must happen for all the situation, a uniform velocity should be 0. When there is resultant, object can't rest. But majority of the situation, object is at rest, no, when the resultant is 0. Special situations, object will be moving even though the resultant is 0. That means already that object should be already moving. At that situation, it can happen. So there is a chance, so there can be. So A and B are correct. We can go for that. First one, forces acting individually, this is possible for, it is correct for one force. But if there are multiple forces, all the forces, like we can say like this, they decide and they get together and decide and move towards only one direction. So there they don't act individually, they act collectively. So because of that situation, here they have put always, no. If they put forces may act or can act individually, then okay, there are possibilities. But here they are saying always, no, always it's not correct. So because of that reason, we are like saying the first one is not 100% correct. It's correct, but partially, not for all the situations. So we can go with the answers B and C only. B and C, sorry. Maybe third one as the answer, B and C. Because B is always 100% correct. C, they are saying can go at a uniform velocity. Yes, there are situations, but this is special situation, not the normal situation. In the normal situation, or when the resultant force is 0, object will be at rest. But outer space, this can happen. Frictionless surface. When the object is already moving, this can happen. Even friction surface, when the object is already moving, then this can happen. I hope you all are clear. Question number 14. Which of the following can be explained by the equilibrium among three forces? Equilibrium among three forces, there are two situations, no? One situation is non-parallel, other situation is parallel. Both situations should be considered when answering this. What is the difference between collinear and coplanar? I explained earlier. Collinear is in the same line of action. They are also coplanar. But the meaning of collinear means same line of action. Coplanar means even collinear are falling in the same plane. All the other forces, for example, this kind of a force. Balana, this will be in the same plane, 2D plane. That is only coplanar, in the same plane. If you are drawing it in a paper, you can draw it, not 3D. Now let's say there is a force going upward, force going downward, and another force coming out of the screen, coming out of your phone. Then that is a 3D diagram, no? Up and down 2D. But if a force is coming out of the screen, then it becomes 3D, then it's not coplanar. Are you clear? In our syllabus, all the questions are related to planar.
Which surah? Which page you said?
Now, Balanna, equilibrium under three forces. Equilibrium of an object subjected in a spring balance. This is the spring balance is the Newton balance. No? There is a spring inside, and here the weight is there, and the object is hung. Tension is acting upwards. Weight of the object is acting downwards. So this is two forces, upward force and downward forces. Two forces acting collinear up and down, not three forces. Equilibrium of a floating object floating. We have completed this lesson in our theory classes. There are two methods. One is partially floating. Can you all remember Archimedes? There, the object's weight is acting and the upthrust is acting throughout the object. So it's not three forces. You can generally say two forces or multiple forces. So that is also not coming for that. Then equilibrium of an ordinary pan balance used with weights. This band balance, have you all seen? Old days they used to have it. And it's hung. There, this weight, and the upward tension. It's equilibrium under three parallel forces. Yes, we can go to that answer. Equilibrium of a book kept on a table. Yes, someone earlier asked, what is this reaction force? I will explain that. Now, let's say this is a book or a box kept on a table. Okay. So, the weight of the object will be acting on the table, no? This should be straight line. Okay, tell me, what is this center point where the weight of the object starts? We draw the weight of the object at the center point. What is that point known as? A special name given to that point? Anyone has an idea about it?
Center of gravity.
Yes, that point is known as the center of gravity. Uda, give me a minute. Our pygmy has come. I'll go and take the parcel. Uda, give me 2 minutes. I'll just go down and come up quickly. Okay, let's continue. Sorry for the disturbance. Only one. Okay, so so the center of gravity is the point, and this is the weight shown by the downwards arrow. We call it W equals mg. Then when the object is exerting a force on the table or the ground, to balance that, the table will exert a force. The weight of the object is generally known as action force, and the reply is reaction. Here, because it is contact, because of the touchingness, because they touch each other, now this force is given. So we call it normal reaction force. Are you clear about the wording normal reaction force? Let's say the weight of the object is 50 Newton. Actually, the normal reaction force also will be 50 Newton. No, then only it is balanced. If the normal reaction is greater, the object will fly up like magic. But normal physics, it doesn't happen. So therefore, both the forces are equal. This is only normal reaction. Earlier someone asked, I was unable to answer it. Clear? Yes. So equilibrium of a book kept on a table, that is also two forces. So the third one is the answer, the pan balance situation. So you all should know this is only known as the pan balance. One is like this, then downward, downward, and here is the turning point or the pivot point. That's the upward force. Or else, generally it is hung like this. So tension is there in the string, weight of the object, weight of the object. So this is known as three forces which are parallel to each other. Floating on water, can you all remember? Last week in our theory classes, previous weeks we did. One is floating partially submerged. There the weight of the object is acting. Who balance the weight of the object? Upthrust force. This is partially submerged object. Then we have another situation called fully submerged object. There also weight of the object is equal to the upthrust which is acting upwards. That Archimedes whole story, we did that. There are no normal reaction force. No, there are no normal. That normal reaction force only here, because it is water, we give a special word, upthrust. Hope you are clear about it. Question 15. What is the resultant force and the direction? Very simple, no? Look at the directions. All are same direction. 5 Newton, 10 Newton, 15 Newton. Directly you can add 5 plus 10 plus 15. Totally 30 Newton towards the east direction. 30 Newton towards the east direction. This is north, south, west and east. So if they come up with directions, you just put this and find the direction. This arrow is pointing this way, east direction. Fourth one is the answer. I hope you all are clear about it. Then object of mass m placed on a smooth horizontal table is moved by applying a horizontal force F. Now here they are playing with words, not the numbers. So there is an object mass m placed on a table and force F is applied on it. If the mass of the object is doubled and is moved by applying the same horizontal force, the new acceleration with which the object can move is, we'll write an equation. First situation, F equals m, we say a1, first acceleration. Second situation, we are doubling the mass of the object and we are applying the same force. F equals 2m, that situation A is A2, different acceleration. But both the forces are same, right? So I can equate equation number 1 and equation number 2. I am doing this in a maths method. So MA1 is equal to 2MA2. I am equating the forces because they say both situation forces are equal. M and M will get cancelled. A1 is equal to 2A2. That means when you compare the second situation to the first situation, you send the 2 to the other side. A1 divided by 2 will be equal to A2. The new acceleration is half of the first acceleration. Half of the acceleration of the first instance, yes, that is the correct answer. Twice the acceleration of the first instance, no. Equal to the acceleration of the first instance, no. 1/4 of the acceleration of the first instance, no. Are you all clear about it? Sorry. Yes, that question I'll do it again and show because they are playing with the. If there are numbers, it's easy for us. But without giving the numbers, they are using words. So let's say for situation M and a force is applied. So therefore the object will move with a acceleration A1 first instance. Then second instance, they are keeping double the mass. Okay, double the mass. That means 2m, no? And applying the same force. Actually, Puta, it's like this. There is a thin fellow. You're pushing that thin fellow with a force, then you will get acceleration, no? Then you're taking another fat fellow who is the double the weight of that thin fellow and applying the same force. That fat fellow won't go with that much of acceleration, no? Acceleration will be half. Practically also you can think like that. But mathematically, how to prove this? Put an equation. F equals MA1 for the first situation. Second situation, same force value. F equals M plus M 2M A2. Now this F and this F are equal. That means you can equate both sides, no? So MA1 is equal to 2M A2. M and M are same M, no? Here double, here single. M and M, according to maths, you can cut. The relationship between acceleration of the first situation and acceleration of the second situation, it's like this. Acceleration of the first situation, acceleration of the second situation, A2. So if you take A2 separately, this 2 will go to the other side, a1 divided by 2. That means if this is 10, 10 divided by 2 will give you a2, which is 5. So acceleration is, second situation, reducing or is half of the first instance. First instance accelerations, half is only the acceleration for the second instant. This one, mathematically, I am proving it to you. Practically, you can think that when the mass doubles, acceleration will reduce by 2 times. Again, it will become half. If the mass is increased by 4 times, acceleration will become 1/4. Like that, you can get it practically, logically also. But this equation wise, if you are able to prove it, superb. The ones who are good in maths, you all can use this method to prove it. Yes, so first one is the answer. The new acceleration is half the acceleration of the first instant. Hope you all are clear about it. Question 17. The phenomena that agrees most with the Newton's third law. Every action has an equal but opposite reaction. Every action has an equal but opposite reaction. The rolling down of a stone that is at the top of the mountain, actually that is due to potential energy getting converted to kinetic energy. Change in the direction of the motion of a moving body. Rebouncing of a ball that strikes on a floor after falling from above. Yes, that is good one. A ball comes, knocks on the floor and rebounds. Action when it knocks, reaction. Reaching the maximum velocity of a coconut that falls from above as it is about to touch the ground. That is general, no? When an object is falling down, velocity will increase, and then maximum velocity at the bottom is due to there is an equation v equals u plus at, no? Due to the acceleration, velocity increases and reaches maximum. That is nothing related to Newton's third law. Even the second one, the change in the direction of the motion, actually it's a normal force, not the action-reaction force. The rebounding, bouncing back, that is action-reaction situation. The third one is the most suitable out of all this. Question number 18. A photograph of weight W is hung on the wall. One minute. Yes, the photograph of a weight W is hung on the wall with the help of a nail is shown in the figure. The tension of the strings are P and Q. The figure is not given, no? Here may be figure. P, Q and W, no? P, Q and the weight of the object W. Forces P, Q, W act on the same plane. I told you in our syllabus, all these are same plane, coplanar. Yes, A is correct. The sum of two forces, P and Q, is equal to the force W. Can we use the word sum or addition here? Sum means addition. Because of the word sum or addition, the statement is wrong. What is the best word to be used here? If you want to get the angle and get the answer, what is the word to be used here? Earlier we did this question, then I showed you the three this one. Concepts related to it, yes. The resultant of of forces P and Q. Separately, you have to find the resultant of this. That will be equal to the force W and opposite in direction. Equal in magnitude and opposite in direction. But because they use the word sum or addition, that statement becomes totally wrong. But they can use sum or addition for this type of a situation. That is no problem. Because directly you can add. Those are known as parallel forces. Now we are talking about the non-parallel now. So this situation only, you cannot just directly add. There is a special addition you will learn in A level. So for now, we just call it resultant addition, not the normal addition. So that's why we have to use the word resultant. See the resultant of P of the two forces P and Q acting on the photograph acts against the force W. Yes, the resultant of P and Q will be acting like this. It is opposite to W. C statement is correct. So out of the above, the correct statements are A and C, second one. Are you clear? See, one small word, word sum made that whole B answer wrong. No? So you have to be very careful. Question number 19. The momentum of a person of mass 50 kg walking with a uniform velocity 3 ms minus 1. Very simple. What is the momentum equation? Momentum equals mass into velocity. The simple equation is P equals mv, m into v. Mass of the person is 50 kilograms. Velocity is 3 ms minus 1. So 150 kg ms minus 1 is the answer. But here they have just given the format of the answer again in the substitution. First one is correct. 50 into 3 ms minus 1. Here addition wrong, division wrong, 3 divided by 5 that is wrong. So if you are getting the answer, you will get 150. Unit will be kg ms minus 1. Hope you all are clear about it. Yes, the last question for the day, 20th one. Consider the following statement. Opening a tap. Okay, now in our syllabus, O-level syllabus, opening a tap means what type of a tap? Nowadays, you all have sensor taps, infrared sensor. When you keep the hand, it will start working. During Corona, you press from the leg, the tap will start working. But in our syllabus, whenever they say tap, think of that old toilet taps, that Yakada taps, which are having two things like this. So there we apply couple of force to rotate that tap and open or close it. So consider the following statement. Opening a tap. This tap. This tap is you open by using couple of force method. A force from this side and opposite force from this side. That's how it rotates. Detaching a nut using a spanner. There is a nut. By using a spanner, you're rotating and opening it. So this is moment of force. First one is couple of force. Second one is moment of force. See, opening the door using a key. Now, here you might get a confusion. Now, here more confusion. When I say opening the door, some students think pushing and opening. Pushing and opening comes under moment of force, no? Because you apply a force, there is a distance. But here they are talking about unlocking the door using a key. That means you put the key in and then unlock the door. The wording should be better. Now this is directly from the past paper I have taken. That's why they have put opening. The proper word should be unlocking the door using a key. How do you use a normal key? Couple of force, no? Pushing the door and opening the door is moment of force. Unlocking the door by using a key is couple of force. So here, which of the following instance couple of force acts? So obviously A and C. The thing is, Whenever they say tap, you should remember that normal tap. Whenever they say opening a door, it's normally pushing and opening. By using a key, if they use the word key, they're talking about unlocking the door. Unlocking the door. Are you clear? So English medium students, we face translation problems like this. It's very common because they, for O level, normally they make the papers in Sinhala and translate to Tamil medium and English medium. So therefore, we get a lot of translating problems, some grammar problems, but we have to get used to that. Okay, we can't use our posh hi-fi English and say, no, this statement is wrong, so I'm not going to answer the question. We have to adapt to their method. Okay, so when doing the past papers, when you come to grade 11, I will be doing past papers every week. Now, today also, we have our grade 11 past papers for the grade 11 students. We have completed 2017, 18, 19, and we have started 2020. In the middle, we have completed separately 200 MCQs. So like that, there is a big plan. That is from the second term of your second term of grade 11, past papers will be starting. So when you start the past papers, you will come across a lot of grammar problems and translation errors. We have to get used to it. Are you clear? So I hope you all are clear about this. So again, we will be meeting in one of our grade 10 paper classes. This is that spanner thing. Here, this is the pivot point. Only one force is there. Then it's not coupled. It is moment of force. So again, most probably next month, first week and third week. Next month is October. First week and third week, we will be having our grade 10 free paper classes. So until then, we will be meeting in our theory classes, and the reproduction lesson seminar is going on. We'll be meeting in that. The ones who are already coming to my classes. Physical class students, as usual, will be meeting. Yeah, so do the revision. Clear all your doubts with the first term, second term things, and prepare for your upcoming grade 11 classes. Now itself, okay, get that O-level feeling and start working hard. In another 3 months, your seniors, the 2025 batch, will be finishing off with their O-levels. Once they finish, our full focus will be your batch. So 2026 O-level students, be ready, because your exams, you all won't get extra timing. You all are the 2025 are the last luckiest batch who are getting extra time, because their exams will be held in February. But you all confirmed December 8th. So therefore, we don't get December and January to do the revision part. But the other batches, December we did full revision, January we did revision. Some batches, the exams were in March. Then February we did full revision. All that time was their full syllabus recap and that and this. But when they are having it in December, by November last 2 weeks, we have to stop all the classes. Then only November first 2 weeks, you will be getting a chance to do the revision. So therefore, make sure your batch is going to be a little bit tight for you all. The timing is changing coming to December. So now itself work hard and do as much as possible papers. Attend the classes, watch the recordings, and make sure you understand science clearly without just memorizing like a parrot. Okay, good night to all of you all. Okay, then Assalamu alaikum. Good day to all of you all.